Hello everyone, in this video tutorial let's discuss concept regarding wireless HART, where HART is an acronym for Highway Addressable Remote Transducer. This wireless HART has been developed as wireless extension to industry standard, and it's an acronym for Highway Addressable Remote Transducer Protocol. HART is most used communication protocol in automation and industrial applications that require real-time support with a device count around 20 million. So here you can see the device count, that which is of very large magnitude and that which in turn needs real-time support. So basically HART is most used communication protocol in automation as well as industrial application. It is based on superimposing digital frequency shift keying modulated signal on the top of 4 to 20 milliampere analog current loop between different components. So here if I consider two different components, component 1 and component 2. So here interfacing is provided between these two by subjecting by superimposing digital frequency shift keying is overlapped on an analog current loop of 4 to 20 milliampere. So that is how this HART is actually realized. This HART provides master-slave communication scheme where up to two masters are accommodated in a network. Wireless HART relies on 802.15.4 physical layer standard for the 2.4 GHz band. So because this 802.15.4 provides physical layer support for 2.4 GHz as well as 915 MHz and 868 MHz, and this wireless HART specifically uses 2.4 GHz band. Moreover, a TDMA based MAC protocol is defined to provide several messaging modes, and these several messaging modes are one-way publishing for process and control values. Second type of messaging is spontaneous notification by exception, ad hoc request and response. Ad hoc is something when necessary to create. Ad hoc request and response. Auto segmented block transfer for large data sets. So this wireless HART makes use of this TDMA based MAC protocol. MAC is medium access control, and it provides several messaging modes. One is one-way publishing, only unidirectional, followed by spontaneous notification if at all if there is any exception, and request and response kind of ad hoc messages, and auto segmented block transfer for large data set. This is the diagram that which shows wireless HART architecture. So this thing consists of wireless field devices, wireless HART field devices that which are distributed over this entire network, and in turn these field devices are in turn connected to these gateways. So here gateways are the ones that which acts in between wireless infrastructure and wired infrastructure, wherein in wired infrastructure we have network manager, process automation controller, and host application. So all these things will interact with this wireless infrastructure through gateway, and in turn these wireless HART field devices consist of sensors and controllers, and they do also have redundant path table based routing. So if at all if any node fails, they can have extra paths to reroute their data, whatever that they have sent, that they have sensed. So here all these nodes actually can act like a source or a router. Source is something that which collects the data, that which senses the data, process it and communicates it. That's a source node. And router is something that which passes the packets that which is relayed. And then we have this on the other hand of the wireless infrastructure, we have these adapters. These adapters provide backward compatibility with that of existing wired HART devices. So HART is a technology that which has been continuously been evolving. So thereby initially they had HART devices that which were wired based, and thereby this adapter is something that which is providing an interface that is backward compatibility between wireless and wired hard devices. And finally we have these handheld devices uh, that which has onboard trans receivers, and this is basically used to assist on-site access. So this network manager is something that which schedules slots, and it maintains routing table as well as it manages the entire network. So this is about wireless HART architecture and its components. The five types of components are defined as below. Wireless HART field devices. These are sensors, and these include sensors and control elements that are connected to process or plant equipment. Second one is gateways, and they provide interface between wireless portion of the network with that of the wired infrastructure. As a result, host application and controller can interact with the wireless HART field devices. Network manager maintains operation of the network by scheduling communication slots for devices, determining routing tables, and monitoring health of the network. Wireless HART adapters provide backward compatibility by integrating existing HART field devices with that of wireless network. Handhelds are equipped with onboard transceivers to provide on-site access to wireless network and interface with the wireless HART field devices. At physical layer, IEEE 802.15.4 standard is employed. TDMA based MAC protocol is used at the data link layer. Network topology is defined as mesh network, and each device can act like source or router. And it also maintains a table based routing so that multiple redundant paths are established. The transport layer provides reliability on end-to-end path and supports TCP like reliable block transfer for large datasets, and that which we have already seen in type of messaging formats, messaging modes that which wireless HART provides. It provides auto segmented block transfer for large datasets, that which is like TCP. And in our next video we'll go through this wireless sensor network architecture.